Last week, a colleague asked me, how long does it take to deploy Kafka on OpenShift? He expected to hear a couple of hours, if everything goes right. I said, 15 minutes. He didn't believe me, so I did it right in front of him. And that's exactly what I'm going to show you in this video. In this video, you'll learn how the Strimzi operator works and what it manages, how to install Red Hat streams for Apache Kafka on OpenShift, how to define a cluster with 6 nodes in KRaft mode without ZooKeeper, how to create topics declaratively, and how to test everything end-to-end with a producer and consumer. Anyone who has configured Kafka manually knows the pain. 2 hours deciding JVM heap, creating persistent volumes, configuring networking. If you add ZooKeeper, multiply by 2. And when it finally comes up, you still need to create topics by hand. Red Hat Streams for Apache Kafka, based on Strimzi, transforms all this complexity into declarative custom resources. You describe the desired state, and the operator does the rest. There are 4 types of custom resource that control everything. The Kafka resource for global configuration and listeners. KafkaNodePool for node pools with broker or controller roles. Kafka topic for topics with partitions, replication, and retention. And Kafka user for authentication and ACLs. Each of these CRs can be versioned in Git, reviewed via pull request, and applied via pipeline. First step, install the operator. In the OpenShift console, create a dedicated project called Strimzi Kafka. Navigate to Operators, Operator Hub, and search for Streams for Apache Kafka. Select the stable channel, choose your project, and click Install. The operator installs the cluster operator, the CRDs, and RBAC resources automatically. In less than a minute, the status changes to Succeeded. Second step, define the cluster. The recommended architecture for production separates 2 node pools. The controller pool has 3 nodes that manage cluster metadata via KRaft, the native Raft protocol in Kafka that eliminates the ZooKeeper dependency. The broker pool has 3 nodes dedicated to storing and distributing messages. The Kafka resource configures the version, listeners, and global parameters like replication factor and min insync replicas. Notice we set replication factor to 3 and min insync replicas to 2. This guarantees durability even if one broker goes down. The first KafkaNodePool defines the broker pool, 3 replicas with broker role and JBOD storage of 10 GB. Apply all resources with OC apply. In 2 to 5 minutes, 6 pods will be running. No ZooKeeper, no scripts. The second KafkaNodePool defines the controller pool, 3 replicas with controller role and 5 GB of storage. Controllers manage metadata via the Raft consensus protocol. They don't handle client traffic, so they need less storage than brokers. Third step, create topics. No Kafka-topics.sh. Topics are custom resources. This Kafka topic defines the topic orders with 6 partitions, replication factor 3, and 7 days of retention. The topic operator reconciles continuously. If someone changes the topic manually, the operator overwrites the change and maintains the declared state. Fourth step, end-to-end test. Using the official Streams image, create a producer pod that connects to the cluster bootstrap service and sends messages to the order's topic. In another terminal, create a consumer that reads messages from the beginning. If everything is configured correctly, messages you type in the producer appear instantly in the consumer. Messages flowing. Cluster functional. 15 minutes. This cluster is a functional starting point. For production, the next steps make all the difference. Rack awareness distributes replicas across availability zones. Authentication via Scram SHA or MTLS using the Kafka user CR controls access. Monitoring with Kafka Exporter and Prometheus tracks lag, throughput, and broker health. And Mirror Maker 2 enables cross-cluster replication for disaster recovery. To recap, in 4 steps in 15 minutes, you went from 0 to a Kafka cluster with 6 nodes, KRaft mode, no ZooKeeper, declarative topics, and a working end-to-end test. If you want to dive deeper into high availability patterns, check the article linked in the description. If this content was helpful, leave a like and subscribe. Thanks for watching.